Good morning, afternoon, or evening, wherever and whenever you are. My name is Ben, and welcome to the Pixel Platformer series. This is part 12. This series was made possible by all of the people who support my channel by purchasing my Godot course. There's a link in the description or in the pinned comment if you're interested in that. In this video, we're going to add in checkpoints to our platformer. Now, this is a video that I've had some issues with in the past, so hopefully this one goes well. I've had to scrap a few versions. The first thing we're going to fix though is if we run the game here, every once in a while this guy will hit the bottom here of the loop and freak out, like appear up here at the top. And I noticed that it's worse if you go into the moving spike enemy and set the animation to call where is it? Instead of using idle, to use physics process. And if you do that and run, then it happens more often. But it was happening before on idle as well. I'm not exactly sure what's going on. My guess is that it's trying to apply delta to this movement, and what's happening is it's slightly overshooting the unit offset because of the delta calculation. That's a guess. I don't actually know why. However, in an attempt to remedy this problem, we can set the process. We can keep the process mode on idle, and then we can come into oops. We don't want to reset on save. I wonder if setting the playback to immediate would be a solution. I don't know exactly. Oh, that's for method called track, so that wouldn't matter. So what we do is we come into path bounce here, and we can click on our little key here. And when you click on it, you can see in the inspector, we get the values of the key, its easing, its value, and the time that it's at 3 seconds. We're just going to set the value to 0.99 or 0.98. And this seems to solve the problem. Although if it was delta, then you'd think the physics, changing it to be physics would help. But we'll set it to physics again and just make sure that it looks like it's working better. So instead of just going all the way to 1, we just do 0.99, and that seems to fix it. We'll leave it on idle though. We'll leave it on idle process. What did I just do? Oh, I accidentally clicked on the asset library. Man, I am misclicking a lot of buttons today. Okay, there we go. So that's the solution, or I guess the workaround for that. I'd be curious if anybody knows exactly what's going on there, and if there's a specific solution that we could apply instead of just going to 0.98. But now it looks much better. So the first thing we need to do here is we need to allow our player to die without just resetting the scene. Because right now we're just resetting the scene. So if we come into our player here, we come into the script for our player, we should have our player die function, and here we're resetting the scene, playing a sound. So what we want to do here is, instead of resetting the scene, we're just going to do cue free. And there's going to be a problem when we do this, and you'll see what it is here. So, okay, player dies, boom, cue free. And the camera gets switched around. That's because the camera is actually attached to our player here. And so when we destroy the player, it destroys the camera. Now there's different solutions for this problem, but the solution that I tend to use is to use a RemoteTransform node. So what we're going to do is we're going to click on our camera here, and we'll actually right click on it and do copy. And we'll come into our world scene here, click on the world, and click paste. Okay, so we've pasted our camera inside of our world scene. Now we can, and it should show up down here. Now we can go back to the player, and we can delete the camera. because we've got it in the world scene now. But now our camera doesn't follow the player, it's just in the world. But we can click on our player, the root node, and add a remote transform 2D. So what a remote transform node does is you give it a path to another node, and it will move that node along with it. So if we give it a path to our camera will follow this node, which, because it's a child of our player, will follow the player. And this allows us to force the camera to follow the player while not having the camera be a child of the player's scene here. But we need to have a way to assign a path, and usually if you click on this, it's going to try and let you click on a scene or a node inside of your current scene right here, and you can see we can't access the camera from here. So we need to assign this path in code, and it's actually pretty simple. So we'll come into our player and we'll make a new function. And let's minimize a bunch of our other functions for now, just so that our code doesn't have all the functions open. At least not all those. We'll leave this up, it's fine. We can get rid of our states too. We'll just have the physics process. Okay, so here we've got our player die. Let's make another one called connect camera. And we'll pass in a camera node. Now all we need to do here is get the path to the camera, so we can do var camera path equals camera dot get path. Once we have the path, we need to get access to our remote transform. So let's do on ready var remote transform 2D. We'll get access to it. And then down here, after we get the path, we can say remote transform 2D dot node path. What is it called? I don't remember the property. Remote path. Remote path equals camera path. So this allows us to connect our camera to our player's remote transform 2D through this function. We just have to pass the camera into it. And we can come into our world, and here in the world script, we can get access to our player, which is right here, and our camera, which is right here, and we can connect them together inside of our ready function. So on ready var camera equals camera 2D, on ready var player equals player. Then here in our ready, we can say player.connect camera, and then pass in the camera. Pretty easy. Now when we run the game, our camera gets connected to the player, and if we die, the camera doesn't get destroyed anymore because it was just following the remote transform, which that remote transform is no longer around, so it can't force the camera to move, and the camera just stays at this position. Now we need to respawn our player though, after this. And to do this, we need to allow our player to talk with the world. And we could do this through two ways. We could create a signal inside of our player and have the player signal to the world. But we'd have to connect that signal every single time a player was destroyed, because when we create a new player, that player will no longer be connected to the world scene. It would be a brand new one. It wouldn't be this one. And so basically, that solution, while it can work, isn't the one that I want to use. I want to create kind of a middleman between our player and our world. And for this, I like to create an event singleton. So we're going to create a new script. We'll right click over here. We'll do new script and we'll call it events. And it can inherit from node. We'll just hit create. Now inside of our event singleton, if I can find it, here we go. We'll just create a signal and we can do our own custom signal. Call it signal, player died. There you go. That's all we need. So it's just a middle ground. Now what can happen is the player can emit this signal and the world can be connected to this signal. But since our event singleton will never be destroyed, the world doesn't have to reconnect to it all the time. It just connects once in its ready function. So that's what we're going to do next. But we do need to make sure and make this a singleton or an auto load in Godot. So we'll come to project settings, auto load. We already have our sound player. Now we'll add our events.gd. Now the sound player was a scene and events is just a script. And the difference is that because events is just a script, it doesn't have to have a scene structure. It doesn't have to have children nodes. Whereas like with our sound player, it was a scene. We needed those children nodes because it accessed those. But our events doesn't need it. It's just a script. Although Godot will create a node. Since it extends node, it will actually create one when we run the game, and I can show you that. Okay, now we're going to come into our world and we're going to connect to our event singleton. So events. So connecting to a signal in code can be a little bit tricky, and we'll go through it here. Events.connect, player died, self on underscore on player died. So this is how connecting a signal in code looks. You have the object that contains the signal, dot connect the signal, comma, the object you're connecting to, or the object that will receive that signal, and the function that will be called when it receives that signal. So our event singleton has, and it helps me to kind of pair them together. So the object with the signal on this left-hand side, and then the object with the function and the function on this right-hand side. Now we need to actually make that function. And I'm very looking forward to Godot 4 when we don't have to use strings here. Make sure these match perfectly. Okay, so now we have a function that gets called whenever our player dies. And this function gets called inside of the world. Although we need to still signal. So we'll come into the player. We'll come into our player died. And right here, we can do events.emit signal player died. We can just emit the signal when our player dies. So now our player will die. It will emit this signal, which is connected to the world node. And it will call this function. Now what do we want to do? Well, we want to recreate our player. And we can do this by loading in the player scene in code. So I'm going to be teaching you now how to instance a scene through code. So we'll start at the top. We'll say const player scene equals preload player.tscn. So what this does is it creates a constant called player scene that loads in our player scene and stores it in this location, this constant. Now this will be called a packed scene. Preload returns a packed scene, and we can instance a packed scene using the instance function. So we're going to create an instance of our player now. Var player equals player scene dot instance. So this takes the player scene and it creates an instance of it and stores it in this variable. Now we need to add that player back into our world, because it's actually what's called an orphaned node, which means it's been instanced, but it's not actually in the scene yet. We haven't added it as a child of anything else. Now we can add it just as a child of our world. So we can say add child player. and that will add the child to the world. So now, our player dies, it emits a signal called onPlayerDied, then it creates the player inside of our world. Well, it instances, which calls this function, instances the player, and then adds it to the world right here. There's a problem though, which is that we actually need to reconnect our camera now because this is a new player. It's a new instance, a brand new instance. So because it's a brand new instance of the player scene, we need to reconnect the camera. So player.connect camera. And there we go. Now we should be able to die and then be recreated in the world. Unfortunately, we're created a clear over on the left-hand side of the screen, right? And we've also got a bug here. Body set shape disabled, cannot change the state while flushing queries, use call deferred instead. And this gets kind of ugly. Basically what's happening is Godot is freaking out because there's some timing issues with how things are being set up. At least that's my understanding of what's going on here. And you could look into the actual C++ code, but that's way outside the scope of this series. So, but yeah, it's freaking out because it says body.get space flushing queries is true. It wants us to use call deferred. Now call deferred is like, it just waits a second before doing it. But we probably want to wait anyways because this is going to be really jarring for our player. So let's do our own waiting. Instead of using call deferred, we'll add a timer to our world. And inside of our world scene, we'll get access to that timer. OnReady var timer equals timer. And now we can just wait a second. We can say timer.start and we'll give it a specific amount of time. So let's do 1.0, so 1 second. Now, in order to wait until our timer is done, we're going to need to use a function called yield. Yield timer. And yield can wait until a signal is emitted. So we can wait until the timer emits its timeout signal, which means it's out of time. So what will happen? When our onPlayerDied script function gets called, it will start the timer and then it will yield, which is like Godot exiting out of this function for a while. It says, see ya, I'm going to leave this function for a while and do other stuff. So it exits out of this function. However, once our timer's timeout signal gets emitted, Godot jumps right back into the function right here and starts doing this part. So let's see if this solves our problem with our little weird bug, our error messages down there. You can see we spawned right on top of the enemy, but you can see we didn't get any error messages this time, and it did work. We were able to spawn there. So we want to spawn at our start location though, where the player starts the game, and we can store that variable inside of our world scene if we want. Var player spawn location. We'll just set it equal to vector2.0 for now, which is where he's going anyways. And then inside of our ready function, we'll say player spawn location equals player.global position. So now we're setting in the ready the spawn location to the player's position when the game first starts, basically. So it'll be right here. Oops, let's come back into our world scene. And then all we have to do is when we add the player here, then we just set the player's position. So we can do player.global position equals player spawn location. So we store it here and then we reset it. We set our new instance of a player to that spawn location. die, respawn right there, and vanish and reappear, apparently. That was strange. Very strange. So we're adding the player. We're connecting the camera. We're setting the player's spawn location. I'm not sure exactly what's going on here. I'm going to yield on get tree idle frame. This just yields for a single frame, and then we'll set the location. I want to see if that gives me any information about what's going on. Okay, so that seemed to work. And what's happening is our player's spawning over on the left-hand side, 0, 0 again, and then instantly teleporting to this location. So that's not good though, because we could potentially run into the enemy over there and die. We want to make sure that we're setting the player's position right to where we want them to be. So this was just a test to try and get me more information. It's not an actual solution to this problem. So I'm going to try reordering this a little bit here. So we'll instance the player, and then we'll set the player's position instead of their global position. We don't need to set their global position. We can just set their position. Then we can add them and connect the camera. I wonder if we can connect the camera after we add them too. Okay. So maybe the problem was using global position, because it seems to be working now, as far as I can tell. Yeah. So trying to set the player's position after was causing issues. Okay, so the solution here seems to be start the timer, yield until the timer is finished, instance the player, set the player's position to the spawn location, then add them as a child, and then connect the camera. And that seems to solve the weird issue we were having with global position. Okay. Now the last part of this video, which is the checkpoints. All of this has been just set up for our checkpoints. So we're going to create a new scene. We're going to go other node, area 2D. So our checkpoint needs to detect when it overlaps the player, and then it needs to update the world's spawn location based on its spawn location. So we'll create an area 2D. For our checkpoint, we'll assign a sprite. Yeah, let's do an animated sprite. Now we need to add some frames. We'll select our characters. No. That's not where our thing is. Where it's tiles. And I think this is 10 by no. Let's see, it's 20 by 9, I think. 20 horizontally, 9 vertically. Yep. We'll scroll in with control and scroll. Now we need to select our flag. I think the flag makes sense as the checkpoint, right? I'm looking at the other stuff here. I don't see anything else that would make more sense as a checkpoint. I guess you could say the button works. There's not like a flag that's not flying though. We've just got these two. So I guess we'll use this. We'll call this unchecked. And then we'll add another animation. We'll call it checked. And we'll come into this again and select these two frames so it can wave in the wind. Okay. Now we have to decide, we can move this sprite up like this, have the origin of our area be down here, but then have our sprite kind of standing on this ground here. We need to add a collision shape. So collision shape, and we're going to do a box, or rectangle, I mean. Set it to be that size, easy to hit. It's a checkpoint. We want to make it easy to hit. We'll name our area to the checkpoint, save it. Then we'll attach a script to it. And we'll attach a body entered signal. Here we go. And we'll say if body, well, if not body is player, uppercase player, because we're referencing the class and not an instance, return. So that way, if we collide with anything that's not the player, we're just going to leave, exit out of this. Otherwise, we'll set our sprite. So onReady var animated sprite equals animated sprite. When I do this here, because sometimes I do it habitually, it just casts this animated sprite as an animated sprite, which gives you autocomplete and stuff. So you can do it either way. I prefer to do it. It's really not that big of a deal. And we can say animated sprite dot play checked, right? Is that what we named it? Got to double check, make sure it's exactly the same. Yes. And we'll set unchecked as the default. Unchecked is the default. Now we can stick this in our world. Stick one up here, I guess. Checkpoint. Grab this. Set it right here. Okay. So there's our checkpoint. Now our player can come up here, come up the ladder, and collide with the checkpoint, and it starts the flag. So we've collided with that checkpoint. Now, we're not actually resetting where the player spawns in the level, right? So we can use our events for this again, our event singleton. We can say signal, checkpoint, or hit checkpoint maybe. That sounds good. And then we need to pass. Now with signals, you can actually send out information with the signal too. And in this case, we want to send out the checkpoint's position. So checkpoint position. Okay. Now we come into our checkpoint, and when the player reaches the checkpoint, then we'll do events dot emit signal hit checkpoint, comma, because now we're going to pass the information. We're going to say position, which is the position of the checkpoint, because this is the checkpoint that is going to emit this signal when the player collides with it. So now when our player collides with the checkpoint, it will emit this signal saying we hit a checkpoint and say the new location. Now our world can connect to this. Events.connect, hit checkpoint, self, on, hit checkpoint. And we'll make this function. Now, remember, this function is going to be receiving information. So it's going to be receiving a checkpoint position. And this can be named whatever you want, but I'm just naming it what makes sense here. Then we'll say player spawn location equals checkpoint position. So this will update the player's spawn location to be the new checkpoint position when we collide with it. So let's see if we can do this. We'll die right here. Boom. Send back to here. Then we'll come up here and we'll run into this checkpoint, and it saves our location. and then we'll die again. And guess what? We spawn up here at the checkpoint. Okay, so now we've got our checkpoint set up. Now technically our player, if you look at our player, you can see that the player's position relative to the origin is centered exactly like this. And I generally like to have their feet or the base of their collision box at the origin. That way when we, currently when we recreate the player, it would be like this. Let me show you. You don't have to do this, I'm just going to show you. It'd be like creating the player right here. And technically Godot's smart enough to push the player up out of the ground when that happens. So it's not causing any bugs currently in what we're doing. However, if we want, we can come over here, select this, hold shift, select all of our children nodes, and then you can just maneuver with the arrow keys to move these up until about here when our collision shape here is right exactly matching up with the origin. And I usually like to do that with platformer characters or other characters too sometimes actually. So something to keep in mind when you recreate your character, it will do that. So we have one checkpoint. Now there is one thing we need to address here is 2 checkpoints. If we have a checkpoint there and say a checkpoint right here, Godot is just always going to use the checkpoint that you most recently went through. And this might not be what you want. You know, if the player goes through this checkpoint and then maybe they backtrack, go through a different checkpoint, and then they die, they're always going to spawn at the most recent checkpoint that they hit. So you might consider actually, this is going to be up to you, but you might consider having a flag that addresses this issue. No pun intended, right? A flag where inside of here we have a variable called active equals true, and then inside of here we say if not active return, and then we say active equals false. This way you can't backtrack and go back to an old checkpoint. So if your player, for example, hits this checkpoint and then they come up here and they hit this checkpoint and then they come hit this checkpoint again, it's not going to matter. They're still going to appear at the last checkpoint. At the last checkpoint they hit in that order. So, right, they hit this one first and then this one second. And so it's going to remember that the second one they hit is the one to send them to. Now this is all up to you as a designer and how you want your checkpoint systems to work. Maybe you do want them to be able to go back to another checkpoint and set that. But just keep that in mind about how this can work. So we're going to leave it like this for now. I hope you enjoyed this video. It's about 30 minutes long, which isn't too bad. And I feel like we learned a lot. We learned about using a singleton for specific events as like a middleman between 2 scenes or nodes that need to talk to each other. We learned about instancing a scene in code and also connecting signals in code. And we did briefly touch on yield here, although that's a complicated subject and we didn't go completely into it. And we also learned about our RemoteTransform, which is a really cool node inside of Godot, has a lot of potential uses. So hopefully you found this video useful and learned something. Thank you so much for watching it, and I will see you all in the next one.